Okay, let's get started. Continue with our testing thing. So last week we talked about a little bit about testing. Some maybe I give you some sense about this white box testing, right? Can somebody help us to remind us a little bit? What is a white box? What is the purpose of conducting white box testing? Yeah. Well, yeah. What can we do with white box text? Let's say this.
We check code in white box testing. We check code, and then based on that, we do the testing.
Yeah, we check the code. Actually, in the white box testing, we make sure that when we make the plan for the testing, we use the flow, the flow chart. We make sure we cover every statement in the code, so that we make sure every line has been executed at least once. So like we touch everything, make sure it's working well, right? So what is like a limitation of a white box? The limitation. Is it enough? We just touch every line of code. Every line of code. Is it enough?
No.
No. Why? Sure, it's no. The answer is no. Yeah, because I won't ask this question if the answer is yes. Right? Yes, no. Why it's not enough, right? Because there are a lot of existing technologies, techniques to do the testing. Okay, so why white box is enough? It's not enough. Okay, it's not enough. White box is not enough because you cannot make sure the functionality is correct by only touching this code, right? Because the logic is there. White box testing is such a at a very low level, and make sure there's this maybe bone arrow, maybe you won't see those arrows that help you to check those arrows, non-point exception, maybe semantics of your code. That's fine, white box, but what we really want to do is testing. More importantly, is we want to make sure the functionalities they are working correctly, right? The system is working what they're supposed to do. Right? So that's why we need some other techniques. So there's another big category of testing. It's called black box testing. So in the black box testing, what's being black and white is actually the code. In black box testing, we don't need to know the details of the code. So we just make the testing plans according to our requirements, the functionalities required there. Okay, so let's see. Let me introduce a whole bunch of black box testing techniques. Now today I want to introduce one of it. It's pretty useful. It's called boundary value analysis. Boundary value analysis. So what is a boundary value analysis? Well, let's go back a little bit. So let's talk about black box. Okay. So black box, we make our plan according to the requirements. We know the functionalities. We know how this functionality they should behave. How they should behave. For example, like this ordering pizza, right? Here, this example. The behavior, this example of ordering a pizza text box. We're now testing, we want to test this text box, okay? So we know when we want to enter the number of orders, right? We know we cannot order. Yeah, let's assume this is a scenario. We want to order pizza, and here in this text box, we want to enter the number of pizzas, a number of orders. Okay, so that is the functionality of this text box and this submit button. So what is this box supposed to do? It's supposed to take the number, right? Is it supposed to take any number you input?
No,
Integer, right? Even negative? No, right?
1 to 10.
Right. You just well, let's assume we take only integer, yes, and we don't want to take negative number because we know the scenario, we know the application domain of this text box. It's ordering pizza. You cannot order in negative, and also usually they put some limited there because if you're ordering pizza, sometimes if it's a pizza, if the pizza stop, a pizza shop, you cannot ordering a whole lot of them, right? So usually they have a range there. So maybe they expect, in this scenario, they expect the order number from 1 to 10 is valid. Okay, so it has to be integer. It has to be 1 to 10, right? So a boundary value, how do we do that? So look at this chart. So we have a range from A to B, which is a normal range, like a 1 to 10. Okay, so when we're doing that test, first we need some value that is normal, okay, like between 1 and 10. So here, x normal, right? And then we need to look at the boundary, which means the up boundary and the lower boundary, upper boundary, lower boundary of the valid range. So on the boundary, we take some values from the boundary. So we take the value exactly on the boundary, and we take a value which is a little next to the boundary. And here is the same for the upper boundary. We take the value which is exactly the boundary and the value which next to it. Sometimes we can take this invalid, a value which is invalid next to this boundary. Okay, so here we take the valid value which is right next to the boundary, and in the upper boundary we take the valid value right before this boundary. And also we can take a boundary here out of this range as well. So that means a value of the boundary, a value exactly on the boundary, then a value right above the boundary, and a value right below the boundary. Okay, like if the range, the boundary value, the range is 1 to 10, then 1 and the 10 is the boundary. So
if they order 0, so it doesn't work.
right. So when we're doing the test, when we make the plan, so we need to take maybe a 5 or 6, which is a normal value, right? And then we need to take this 1. That's a boundary, which should work, right? And then we take a 2, which is a value right above the boundary, right? And then we also need to take a 0, which is a value right below the boundary. So we know that when we take 0, it will have a invalid. It's an invalid input. But if we take 1 and 2, it's valid input. We know this because we know the requirements. We know the scenario application domain of this functionality, right? So, but we cannot test every possible value. It's impossible. right? Because there can be a whole lot of values, an infinite number of values. So therefore, what we do is we take normal value and we take 3 values from boundary, below and above. Okay, so try to make the test cases. That's usually what we do in this boundary value analysis testing. Okay, so for here, let's assume that this is a pizza ordering text box. The values 1 to 10 consider valid. A success message is shown. But if you input other value, it will show like only 10 pizza can be ordered. So what is the test cases if we're using the boundary value analysis technique? So this is what we know about this text box. Can you make a plan for the testing using boundary value analysis? Yeah. So what is the plan? How many value do we need? How many values do we need?
For boundary,
Yeah.
2.
2? No. I mean, if we want to test this order pizza text box, if we want to use the boundary value analysis technique to make a test plan for this order pizza text box, how many test cases are there? 7. I would say 7. So which 7? Yeah, normal value is 1, right? Normal, yeah, and then the lower boundary, we need 3 of them. The boundary to the left, to the right, and the upper boundary to the left, to the right, right? So that's my way of doing it. Sometimes you don't take some value above, or you neglect the value below. That's still some other strategy. But the idea is you take normal value and you take some values from the boundaries. Okay, but if we want to make a plan, yeah, here it's order pizza. We check 6, right? It says success. Here it says success. Now let's check 1. Success. Good. Let's check 0. Say invalid number. Right? Maybe 2. Success. So yeah, so far so good. So a 9 is gonna be success, and 10 we expect it to be success, right? And how about 11? Yeah, only 10 pizza can be ordered, right? Yeah, and something like that. Yeah. Okay, so that's how we do the boundary. And you can also combine the boundary value analysis with the equivalence partitioning. So that's another thing I won't talk more today, but today what I want you to memorize is the boundary value analysis. Okay, let's take a look at another example. Here, we want to enter a password. We want to test this textbooks for the password. All right. So the password fields accept the minimum 6 characters and maximum 10 characters, right? So this is the functional requirements of this textbook. So now I need you to make a plan for this. Test cases using the boundary value analysis method. What's that?
Do you change it?
I didn't change anything. That's another example.
Oh, is that not?
It's not pizza anymore. Sorry. So the password field accept minimum 6 characters and maximum 10 characters. We just want to test this single functionality.
It's still 7.
Yeah. So let me know what are the 7 values and what is the expected outcome of those values.
We can include what range of letter they have to use, which character, for example, question mark. Sometimes these are limitations for password.
Yeah. So we forget about those special characters. This is the only thing. This is the only functionality we want to test. So this functionality reads like following passwords fields accept minimum 6 characters and maximum 10 characters. So how can we use the boundary value analysis for this?
Like the normal value is from 6 to 10 characters.
Yeah, so write down, take a piece of paper, write down the test cases and the expected outcome.
It's just for test.
Yeah, just for test cases. You said 7 test cases, right?
No, I know that.
It's 7 test cases, yeah. Actually, we can use 7 test cases, boundary, normal. So what are the 7 test cases here to test this functionality? So are we just, since it's from 6 to 8, shall we just put 8 here, 6 to 10? We just put 8 here and click submit. Is that what we want?
No, this is not normal. This is lower one.
Yeah, this is not actually a boundary at all. So we need a 5, right? 5. So let's say 1, 2, 3, 4, 5. Let's see. Between 6 and 10. Looks good. 5. No, okay, let's do 6. 1, 2, 3, 4, 5, 6. Success. And then we test 7. 1, 2, 3, 4, 5, 6, 7. Good. And then we test 6 to 10, we test 8. Success. And 10. And 11, it should give us invalid, right? So that's how we make a plan for this boundary value analysis. Okay, because why do we have boundary value analysis? What is motivation of boundary value analysis? It's because we just cannot test every possible input, right? So we get something from a range, within the range, and something on the boundary to do the test. Okay. All right. So this is the example of a black box testing technique. So can we do this with white box? Is white box able to detect such kind of error? Can we? How can we test that with the white box testing? Remember, the white box testing, what we want to do is we just want to touch every lines of code. That's it, and we don't even know the functionality. So here, if you want to test the functionality, right? If you want to make a test cases for the functionalities, we use black box strategy. So that's why white box is not enough, right? Because when we're dealing with white box, we usually we do not know the functionalities because that's out of scope of white box. All right. So that's functionality. We test the functionality, black box. That's good. So where do we get all the functionalities of the system? When we're testing the system, we know that this section of code, this text field, is supposed to have some functionalities. But where do we get these functionalities? How do we know that? Let's assume you are in a company, you are working in the testing group. Okay, where do you get these functionalities? Because you didn't implement this code. You do not know what this code they are supposed to do, right?
From the requirement.
Yeah. So we get these functions from the system's functions from the requirements of the system. So we need to do requirements engineering, right? Which is very important step for basically the whole project. Not only the testing. Well, for the testing, we definitely need the functionalities to be specified, right? But for the requirements engineering, it is also very important for the implementation, for the system integration, everything in the system. Okay. And so today, let's also talk about a little bit about requirements engineering. Okay. So again, requirements engineering is also well, you can have a entire course on requirements engineering. So today here we're only going to have a very top level overview of what is the requirements engineering. Okay, so what are requirements? We know that, right? We mentioned that. So and we heard that more or less. We know that when we are doing the requirements, basically we want to learn what the system needs to do, the system's behavior, right? So where do we learn the requirements? Yeah, mostly from the client. Yeah. Yes. And so yeah, let's talk about it. Yeah. So the requirements is a feature of the system or description of something the system is capable of doing in order to fulfill the system's purpose. So it specifies the purpose of the system without specifying how it is built. Goal of requirements analysis is to determine nature of customer's problem. Okay, it does come from the customers. But does customer know everything about the system? No, they don't. We should not assume that because most of the customers, they may not be the professional of software development, software engineering. You cannot assume that all the customers can list every single requirements pretty detailedly to you and the development team. Yeah. So that's why we need to gather requirements, and also we need to do the analysis to this requirement in order to figure out what the real requirements of the system. Okay, so there are two types of requirements: functional and non-functional. Functional is easy to understand. We know the system's behavior, like the system's capability of doing things, like face recognition. Okay, well, the functionality to help user to register a class, a drop class, or payment, make the payment, ordering pizza, place the order. That's functional. So what is non-functional requirement? Sometimes this part is well, it's missing from some of the students well, their assignments, but this is important. Also important parts of non-functional requirements. It can be neglected by some team, but it is a constraint that describes the restriction on system that limit our choice for constructing solution. So example of this non-functional requirements including the performance, right? Where you want to do this search for course, But if that system search the course for, if you like search, I want to see if we have a software engineering course open next 4, but after a week it returns your request, it returns with your answer that yes, we have that offer. But is that good system? Is that working well? Well, if you only have functional requirements, yes, it's doing the same. But if you have the non-functional requirements, put the constraint there. Like it needs to be returned within a second, 2 seconds. So that helps to further specify the system. Now also that's performance as well as security, right? Security is also another functional, non-functional, very important non-functional requirements for the system. Like you need to have your all the data protected. Usually that's not actually a function, right? But that's a non-functional requirements of system. You need to specify that as well, right? And if you have some other things, like I need this software can be run on some limited resource. Like I want the software, so we have iPhone 10, 11, something like that, right? What is the most current iPhone? Is it 10 or 11? Yeah, okay, 10. Yeah, it's 10. So 10 plus, I guess, right? It's 10 plus, something like that. Okay, so right now, if I'm specifying, okay, I need a software that can be run on iPhone 1, maybe the first iPhone, the very first iPhone. Yeah, that goes to the non-functional requirements. Maybe, I don't know, maybe the client, they may have this kind of requirements at some point because they have a iPhone there, they want to use it, so they have this kind of requirements. It's possible, but that is not function. That is non-functional requirements. Yeah. So how important are requirements? And what happens if we mess them up? So, well, this report indicates only 26% of projects succeed, and 46 majority of it are challenging, and also 28% failed. So why is this happening? The top 5 top reasons for project failure are associated with the requirements. First is because of incomplete requirements, lack of user involvement, unrealistic customer expectations, changing requirements and specification, or no longer need the capability provided. Okay. And the comment from the report is, if you don't nail the requirements, you'll fail the project. If you nail the requirements, you'll deliver. And good requirement analysis, good requirements is one of the top reasons for project success. Okay, so that all tells us, yes, requirements is important. Okay. Yeah. And before we start the requirements engineering, what we need to prepare is we need to have a plan, right? So we need to plan. We need to know what resource do we have, methodology, time needed, and sometimes some organization even perform requirements engineering as a separate activity and price it separately. So if it's a separate activity, we need to plan for this activity as well. So first is plan for requirements activities and agreeing on resources, methodology, schedule, and obtain and organize the agreed upon the resource and methodology. So before you learn the requirements, you need to know what is the capability of your group. Okay, your group has this resources, has this limitation that you need to be aware of that before you actually start the requirements engineering. And during the requirements engineering, this is a model. So what we do is user needs domain information. We gather that information and we elicitate those requirements, and we analyze, negotiate, then we go to the next stage, document them. After we document them, we have a requirements document and the specification document. With that document, we can validate if the requirements are correct. And then from every step, we can actually have the path go to the previous steps. It depends on maybe some arrows there. Maybe you need to go back. But then at last, we need to have agreed requirements. Okay, so it's agreement between you and the clients. All right, and the major requirements engineering process activity. So that's explained that this diagram. So elicitation, during elicitation, the requirements discovered through the consultation with the stakeholders, which means everyone involved in this project, including clients. And requirements analysis and negotiation, it's we analyze and resolve the conflicts through the negotiation. Because sometimes the users, the clients, they are not very well aware of what they want to do. Sometimes they want, okay, maybe in the beginning they think, okay, maybe the professor should not have the ability to add a new course, right? Because that's what the administration do. Then later on, when they think of the scenario when the professor, he or she wanted to open a new course or an innovative course, they think under that scenario, maybe the professor should have the rights to do that. So they specify another requirements, like another workflow. The professor is adding a new courses. So these two requirements, they may conflict with each other. So we discover that and negotiate that during this analysis and negotiation. And then we do the requirements documentation and we do the validation. Documented, then we check for the consistency and the completeness. Validate. Alright, so that's another model. So here it's basically saying the same thing. Elicitation, negotiation, documentation, and then we have our agreement accepted, right? Yeah. And here in the documentation, we have actually first step as the definition, prototyping, and validation. So this we can later we will talk later in the slides. Yeah. So why is this set of activity important, and why should requirements be documented? So this basically tells you why. So because well, like I said in the beginning, requirements is needed not only for testing, it's also needed for everything in this development. So clear requirements are needed for design and implementation. Documentation is needed to create test cases. Remember how we just did the test cases, generate test cases? We generate test cases through the requirements. From the requirements, we find the values, the range of the values, right? So requirements documentation is needed to create test cases. Also, it's needed to control potential scope creep. Just that we want to make sure we have agreement there, so we don't not to increase the scope. And requirements documentation is needed to create user training materials. Yeah. Okay. And here, requirements elicitation. Yeah. So requirements, there are two. Here we have when we are trying to do the requirements elicitation. So their set of requirements may be given directly to the software engineers. Also, there are a whole bunch of requirements that need to be established by software engineers. Okay, so what is the thing that can be given? It's first something like initial product system requirements. Okay, second, third, follow on release, plan sequence, maybe future versions. Okay, and requirements provide as a part of request for price quotation of a software development project. Okay, and another thing needs to be established by the software engineers is users sometimes have an understanding of only the requirements of relate to their specific job tasks, but there's something that the engineers knows but the clients doesn't know, right? For example, well, there's something maybe they want to the user they propose a step, maybe an algorithm. Okay, the user they may want to maybe doing this a sorting algorithm, right? They want a functionality, a system to help them to put everything, compare a number to each of the other numbers and put them in the correct position. But the software engineer may know a better solution, maybe quick sort, merge sort, which is not understood by the clients. Therefore, this type of requirements may be proposed by the software engineers, and maybe after discussion they may be illustrated there. And the business rationale and goals are not always clear to individual user and needs to be established for prioritization reason. And there may be contradicting and incomplete requirements stated by the user and customers. Yeah, that's all because of the software engineer. They know, most of the time, they know more about the techniques than the actual client. So they know the capability, so they have a different view of the requirements. All right. Yeah, high-level requirements elicitation. We need to seek out the business and the management perceptions and goals for the software project. So this includes the business opportunities and the business needs, justification for project scope, major constraints, major functionality, success factor, user characteristics. Yeah, so that all requires this interaction with business management. Yeah, so it's also called a business analyst. Business analysts. So it's basically we're doing analysis to the business model and how this business is running, so we can elicit this requirements within that application domain. Okay. And when we're trying to elicit the requirements, this is the 6 dimensions we need to think of. So when you think of the requirements from the business workflow, right? And when you think about the data formats, constraints, performance, user interface, existing system interface, which is like so because sometimes you do not develop from scratch. There are some existing system, so it has to think about the interface with that in existing system and individual functionalities. Yes. Yeah. And requirement analysis composed of categorizing and organizing the requirements prioritizing the requirements. Yeah. So that's two things we want to do. Also, we want to start to look for consistency and completeness during the analysis, but most of the consistency and completeness is in the validation of the requirements. Yeah, and when we're trying to classify and categorize the functionalities, the most high level is the functional and non-functional requirements, and other more detailed groupings also exist, like the 6 dimension of requirements here. Categorization. That's one way to categorize them is very high level, non-functional and functional. We talk about that. Here is 6 of them. We can categorize them with their functionalities, business flow, like scenarios, like the functionalities for faculty, the functionalities for students, something like that. Data information needs, like the functionality of maybe dealing those. We have some functionalities. Do not touch the database. We have some functionality. We have interaction with the database, and user interfaces. And other interfaces with the external systems, right? And various constraints, performance, security, reliability. That's more, well, that's 6 kind of like non-functional, yes. But it's not, non-functional and functional is not the only way to categorize requirements. We can also categorize from maybe by this 6 dimension. Yeah. And also we need to give a priority to different functionalities, right? Requirements. Well, that's because we have the limitation in developing. We have limited resource, so we have to give priority. The limitation comes from the time, resource, and technical capabilities, and we need to prioritize in order to satisfy these limitations. So because we have a 3 members team, that means we can maybe we cannot do everything within this week, right? So that's a limitation. What we do in this week, we need to pick the top priority requirements, working on those. Yeah, okay, so when you're doing the priorities, how do you prioritize them? So the criteria include the user customer demands. So if it's something that the core of this function of this system, the user needs, you want to give that high priority. Also, you select the criteria according to this competition and current market condition, anticipated future and new customer needs, sales advantages, existing criteria, critical problems, and in current products. That's not only criteria, okay? So there are a lot of considerations you need to take into you need to think about when you prioritize this requirements. That's really not there's not a standard way to instruct how you prioritize them. It's all about communication and your understanding to the system, to the market, to that business. Okay. They're often subjective, and requirements should be prioritized with the help of many of the stakeholders, like from different viewpoints. Like I said, from business, from market, maybe from the resource, or from a lot of things. Okay. Then this is an example. So that's the requirement number. You have a description of the requirement. You have a resource. You give a priority. Yeah. And requirement status is accepted for this release. postpone for next release. So that's a decision. After you prioritize, you make a decision. Or its current status. Maybe it's after the you said it's accepted, or it's underdeveloped, or it's postponed. And then requirements definition, prototyping, and validation. So once the requirements are solicited, analyzed, and prioritized, more details must be spelled out. 3 major activities which may be three major activities which may be intertwined must be performed. So that include definition, prototyping, and the validation. That's, if we go back to the model, that's all in the documentation of the requirements. So what are these? So this part is going to be in your project. So pay attention to here. So what we do here for the documentation, it's the requirements documentation consists of a precise description of the problem domain together with the requirements. So the requirements are written in natural language. Of course, we're not requiring this formal specification yet. That's another course. But here we're using natural language to specify it, to written the requirements documentation, and specification and contains the definition of the required behavior of the solution system. Or it can be it forms the basis of the formal contract between the client and developer. That's the specification with natural language. We define the system, the behaviors, right? Specify the behaviors, definition of the, and also sometimes requirements definition can also be specified with natural language plus some of the charts. So let me introduce some of the charts and other the charts and other tools, such as this simple input process output IPU description. Here is the requirement number, which is input and input to this function, and the process of this function, and specify the output from the function. Here this input is items by type and quantity. Submit request of items. Yeah, so it takes items and quantity request, and then what it do is accept the item, and respective quantities include error and rejection of items. Then the output is display acceptance, or and ask for confirmation message, or and ask for confirmation message. So that's how we specify the requirements with the IPO, right? The IPU, IPU. Also, we can use the data flow diagram. Remember these symbols and semantics? So data flow. Well, this is how we process data. The process of dealing with the data. And this is the the source or destination of the data, and the data itself, and the flow of data. Let's see this example. Look at this example. So we have a requirements expressed using this data flow diagram. Here, let's see. First, we have this customer, right? Customer make orders, and order is processed. The order is passed from the source, the source customer, from customer to order processing. This is a process. Okay. After the processing, it goes to this packaging, shipping instruction. Yes, the packaging. All right. But when we are doing this order processing, we need to get the data from the inventory. So that's why this data set have the flow into this order processing. Okay. So this is the data, and this is the flow. Inventory info, this is a data store or data set, database. Yeah. and this arrow line and arrows, they indicate the data flow and its direction. And also when we're doing the packaging, we need the package data, and packaging details flow into this process. Okay. Well, also when we are doing this ordering processing, we also need the data from the customer info, like the credit address, credit card address, something like that. We use credit card to charge, and we use address so that we know when we're doing the packaging, we know that the address should be packed there and then deliver that. Okay. So the main process is customer make orders, the system deal with the orders, and then the system pass the data flow to the packaging processing to pack that order. But during this whole process, we get data from all the databases, data stores. Okay. Any question with this data flow diagram? Yes, it's not very hard to understand. And this ER diagram is more about the when you do that in the database, like the order and items. So one order can include M and kind of items. So when you design this database, the requirements dealing with the database, you can use this ER diagram to specify the relations between customer orders, and items, right? Something like that. And also, so data and its attributes, you can also specify it with this entity and attributes specification. Like employee has this attributes, right? And this specified employee has address, name, and age. And the address has attributes of street, city, state, zip. And requirements traceability. So we have the requirements. Yes, we solicitate the requirements, analysis the requirements, and listed all the requirements. But when we're actually using these requirements, we want them to be traceable. So we need the requirements to trace the requirements from the source. We need to trace the requirement to the later steps, like use case, design, implementation, testing, and the final system. And we also need to the requirements to link to some other related requirements. For example, yeah, that sounds complicated, but no, here, that's the traceability table. Okay, so we have a requirements 1, which is specified already. Okay, but we have here the traceability table, which just tell you the requirements 1. It's associated with the design stage, some activity in the design stage, some activity in the coding stage, module 3, and some of the part of the testing, maybe test case 3 and 2 may be associated with this requirements, as well as the other related requirements, because requirements 1 maybe have something in common with 2 and 3. Maybe they work together, or they need to happen one after each other sequentially, right? So with this table, we not only specify the requirements, we have a good way to take good use of the requirements in every stage. And at last is software validation. So what is validation of the software? What are we doing there? We attempt to ensure that the correct functionality for the solution system has been defined. Right? We validate this requirements. So we make sure that the system does what it is supposed to do. We need to validate the entire requirements engineering process and the entire software engineering process to check Is the description of the problem domain accurate reflection of its priorities? Are the requirements properties are the requirements accurately recorded? Is the external design correct? Will the invented behavior of the new system produce the requirement effects? So we want to do the validation, validate the system. And software prototyping is here we're talking about the prototyping is not like a deliverable product. It's something help us to validate. We can validate with help us validate the system. Here we have a low fidelity and high fidelity prototype. Low fidelity is what we call the paper prototype. So use the paper cardboard to represent screens and including arrows and screens, numbers, pages to represent the screen flow. Okay, so while this sounds like very general, very preliminary step, but with the help of this even paper prototype, it helps a lot for you to communicate with the stakeholders, to communicate what do we need to communicate. It's about the requirements. Well, through this prototype, through the demo, even it's a cardboard demo, we can still figure out is the assumptions from both parties, are they consistent? Are we understanding the question correctly? And is the system does what it's supposed to do? And high fidelity is even easier. It's using the automated tools such as Visual Basic codes and screens and direct the logic flow of these screens. Okay, so it's actually something that you can click interactable, but it's not fully functioned. But it's the interface can go from here to there, jump around, so that it demo how the system is working, what is the flow of the system, so that all the stakeholders, they are able to validate, is the design correct, is the functionality, the documentation, the requirement documentation correct. Okay, here requirements documentation structure, we have a IEEE standard process for the software requirements documentation. I've uploaded this IEEE standard in the D2L. So when you are doing your homework, the assignments, the term project, you can use this template. So it includes the introduction, which includes the purpose, scope, definition, references, overview, and also general description, which gives you information about the product, and also the users of the product, constraints, assumptions, as well as specific, and also we need to specify the detailed requirements. Well, we need non-functional and functional, as well as these interface requirements. Yeah. And finally, the requirements sign off. We have a requirement specification, then we need agreed. So we need to sign off this requirements. So this serves as a milestone marker and a final contract between the software engineers and the clients. It serves as a baseline from which any future changes can be monitored and controlled. So that's one of the important meaning of important function and feature of the requirements documentation. So we need to sign off. So it's kind of a contract, and if anything change in the future, this is a baseline there. Okay, and we know what's more we need to aid, how much efforts there needs to be. Okay, all right, so that's about the requirements engineering. All right, so yeah, that's it for today. And remember, so this IEEE standard purpose, IEEE standard has been uploaded to the D2L. So when you are doing this requirements part of your term project, please refer to this IEEE standard. Okay, all right, it's here. All right, thank you very much.